Okay, welcome back here, Mr. Lin. Today we're talking about enzymes. So enzymes are biological molecules. They're proteins that speed up chemical reactions. So up to this point we've talked a lot about chemical reactions. And why do we have to speed up these reactions? Well, sometimes they can happen fast enough in the body. Here's a picture of a couple enzymes. This is a scanning electron micrograph. And you can see they have all these little pokey things coming out. Sort of look like the coronavirus, don't they? And so, in your body, there's all these chemical reactions happening all the time. Digestion, metabolism, cell respiration, reproduction, growth, respiration. And what do I mean by reproduction? Well, your body, is constantly producing hormones, and there are things happening in that department even if you aren't actively reproducing. Of course, you're growing. That's a big one for you guys. And respiration. Now, here we're not talking about cellular respiration, but the actual respiration process of oxygen entering the bloodstream. So a catalyst, and I talked about this a little bit in our discussion of energy and reactions last week, is a molecule that speeds up the rate of the chemical reaction by lowering the activation energy. So this underlined stuff is what's most important with this slide. So enzymes can be catalysts. And oftentimes the name of the enzyme, those last three letters, ASE, gives you a clue that you're looking at an enzyme, and it's a catalyst. So here's the carbonic anhydrase reaction I talked about, and it speeds up that reaction by a factor of 10 million. So this is just crazy how fast the reaction can go if you're catalyzing it with an enzyme. So enzymes basically start chemical reactions in your body, and we need them. They do this by lowering the activation energy. So we looked at a graph a lot like this last week where I have a couple reactants. I have molecule A plus molecule BC. And so we're breaking those chemical bonds. This would be called a single displacement reaction, where this bond is broken and then the B molecule is going to be joined to A. Here's this free energy graph as we need the energy to get this first chemical bond broken, this transition state. And so without the enzyme, we have a lot of energy that we have to put into this to get the reaction to happen. With the enzyme, the activation energy is lowered, and so we call that enzyme a catalyst. So enzymes regulate reactions, but what regulates enzymes? Enzymes are these things that turn on and turn off chemical processes in your body. Things happening in your brain and your nervous system. But what regulates those enzymes? One of the big ones is temperature. So if you get too cold or too hot, that's going to trigger enzymes to begin some sort of chemical reaction to regulate your body temperature. pH, and we'll learn about this one next week, which is the acid-base scale. But if things get too acidic or too alkaline, that can cause the enzymes to go into action to restore homeostasis. And then also regulatory molecules or hormones can also serve a purpose to regulate enzymes. Now this is the main slide I want to focus on today in this little lecture, which is how does an enzyme actually go about doing its job. So what this slide is showing is the lock and key model for enzyme activity. And so this is the enzyme here, this kind of gray blob that has a spot that the substrate can fit into. And so it's called the lock and key model because the chemicals that the enzyme is going to act on, they match up with the enzyme. So we have a very specific enzyme for a very specific chemical process. And so the substrate, the chemicals involved in the reaction, or the reactants, they come in here to something called the active site. And they fit in like a lock and a key. And the enzyme then catalyzes the reaction. It makes it speed up. And once the reaction happens, then we get our products that are released from the enzyme. And so a couple intermediate steps in the reaction involve this enzyme substrate complex. So while the reactants are bonded chemically to the enzyme, you have this enzyme reactants or enzyme substrate complex, which then changes to the enzyme products complex. And then the products are released. And one of the key things in this process is the enzymes aren't used up. Your body doesn't have to constantly make more enzymes. You have all these enzymes already, and then this guy, after it's done, will go back, and it's sort of like an assembly line. And he's ready to catalyze another reaction, one specific chemical process in your body. So that is the lock and key model of enzyme activity.